Good afternoon, students. In the today's class, we will discuss introduction part of the carboxylic acid, the organic compound which contains the carboxyl functional group, that is COOH, are called as carboxylic acid. The general formula can be written as RC double bond OOH, where R is any alkyl group. The name carboxyl is derived from the carbonyl, that is C double bond O, and the hydroxyl OH, because in the carboxyl group these two groups are directly bonded to each other. Here from the carbonyl, the first four alphabets are taken, and in the hydroxyl group, the last four alphabets are taken and joined together to get the carboxyl functional group. Because the C double bond O and OH group is joined together, so the name is derived like this. Then the carboxylic acid may be aliphatic or aromatic. In the aliphatic carboxylic acid, the carboxyl group, that is COOH, is attached to the hydrogen or any alkyl group. In the aromatic carboxylic acid, the COOH group or carboxyl group is attached to the aromatic ring. Whether the group is aliphatic, aromatic, or saturated, unsaturated, substituted, or unsubstituted, the property of carboxyl group will remain same. Coming to the classification, carboxylic acid are further classified as monocarboxylic acid, dicarboxylic acid, tricarboxylic acid, etc. according to the number of COOH groups present in the molecule. The long chain monocarboxylic acid are commonly called as fatty acid because many of these are obtained by the hydrolysis of the animal fats or the vegetable oils. Coming to nomenclature, this can be what named by three methods, that is by the common system, IUPAC system, and the derived system. Coming to first method, it is common system. And the common names are usually derived from the Latin or the Greek word that indicates the source of the acid. They do not follow any rules except that all common names of the acid end with IC acid, that is carboxylic acid, IC acid. For example, if the if the compound contains three carbon atoms, then it is called as propionic acid. If it contains four carbon atoms, then it is named as butyric acid, like that. Okay. In the common system, Greek alphabets, that is alpha, beta, gamma, delta, etc., are used to indicate the position of the substituents. The carbon atom adjacent to the carboxylic carbon is designated as alpha, and the next carbon on the chain is designated as beta, and that to next carbon is designated as gamma, and so on. See the examples here. Let us see the example. In this first example, the carbon which is attached to the carboxylic acid is designated as alpha, as I said you earlier. To that alpha carbon, methyl group is attached. So we are writing this as alpha methyl. Here three carbon atoms are there, so we are writing it as propionic acid. Okay, next example is here the carbon which is in the second position to the carboxylic acid is designated as beta, right? To the beta carbon, methyl group is attached, so we are naming it as beta methyl butyric acid, because four carbons are there, so we are writing it as butyric acid. Coming to IUPAC system, the carboxylic acid are named as alkanoic acid. Here E is removed from the alkane and we are adding oic acid. Let us see few examples and name it under the common system and the IUPAC system. HCOOH is named as formic acid under the common system, whereas in the IUPAC system it is named as methanoic acid because it contains one carbon. Coming to CH3COOH, it is named as acetic acid in the common system, whereas in the IUPAC system it is named as ethanoic acid because it contains two carbon here. Next one is CH3CH2COOH. It is propanoic acid. And coming to IUPAC system, it is propanoic acid we are writing. Okay, coming to CH3CH2CH2COOH, it is butyric acid. Here in the IUPAC system it is butanoic acid. Coming to last example, it is CH3CH2CH2CH2COOH. It is named as valeric acid in the common system, whereas in the IUPAC system it is known as pentanoic acid. For naming higher members, the longest continuous chain containing the carboxyl group is selected. The number of carbon atom in this chain gives the name of the parent alkane. The position of the substance is indicated by the number. The carboxyl carbon is always given number 1. The carbon adjacent to it is given the name 2, and so on. Let us see examples now. The longest carbon chain contains 6 carbon, that is hexa. Okay, here in the carboxylic acid it has to end with the oic acid, right? So we are writing it as hexanoic acid. In the third and the fourth position methyl group are there, so we are naming it as 3,4 dimethyl hexanoic acid. Coming to second example, the numbering the carbon contains 3 here. Okay, so we are writing is prop, and here in the carboxylic acid it has to end with the oic acid, so we are writing it as propanoic acid. In the second position bromine is there, so the name we are giving it as 2-bromopropanoic acid. Coming to third system of nomenclature, that is derived system. Some carboxylic acid may be named as substituted acetic acid. Here CH3 thrice CCOOH, it is named as trimethyl acetic acid, whereas C6H5CH2COOH can be written as phenyl acetic acid. Coming to physical properties, lower carboxylic acid, that is up to carbon 10, or liquid which is having disagreeable odor. Higher members are wax-like solid and almost odorless. Coming to boiling point, the boiling point of the carboxylic acid increases regularly with increase in the molecular weight, whereas the melting point of the carboxylic acid increases irregularly with the increase in the molecular weight. The even member have markedly high melting point than the odd member. You can observe this chart and you can analyze it. Coming to fourth point, the boiling point of the carboxylic acid are higher than those of the alcohol of the same molecular weight. Coming to fifth point, the first 4 members are completely soluble in water. This is due to the ability of the carboxyl group to form hydrogen bond with the water molecule. As the hydrocarbon chain in the acid lengthens or increases, the solubility of the acid in the water falls off rapidly. Carboxylic acid are readily soluble in ethanol, ether and the benzene.